Good morning, students. In the previous video, you have seen until smart antenna techniques. That is, we were discussing about the various 4G technologies. So next, let us see. In this video, you will be seeing three more topics on 4G technologies. That is the OFDM, MIMO technology, adaptive modulation and coding with time slot scheduler, and finally cognitive radio. And we will also see some of the basics of SDR technology. Now coming to the first topic, that is MIMO OFDM technology. It is the combination of both the OFDM, that is the orthogonal frequency division multiplexing, and MIMO technologies. As you know, the basic idea of the OFDM technology is using a large number of parallel narrowband subcarriers, that is they will also be orthogonal to each other, so that a large number of subcarriers will be used instead of a single wideband carrier, that is for transporting the information. That is the main idea of OFDM. And what is the advantage of OFDM is that it is very easy and efficient in dealing with multipath signals, and it is also robust against the narrowband interference. So this is what is about OFDM. And coming to MIMO technology, MIMO technology uses multiple antennas both at the receiver side and at the transmitter side, so that it leads to the increase in capacity of the wireless channel, and also the signal to noise ratio also gets improved. So we have seen what is the advantages of OFDM and MIMO, and now what we are going to see is the combination of both. That is, what is the advantages of combining these two technologies in the 4G technology. Now MIMO, let us see what is the use of it. MIMO is well suited for OFDM, as it is possible to process the time symbols as soon as the OFDM waveform is currently designed for the channel. And also the OFDM and MIMO techniques can be combined to achieve a high spectral efficiency and increased throughput. The signal transmitted using the let us see how the signal is being transmitted and received in this particular technology. So look at this figure. So the signal is transmitted using M transmitting antennas, and it is received by N receiving antennas. Then the processing of the received signals will be done, and what we can infer from that is that the quality, the range and the spectrum efficiency of the received signal is being boosted. The OFDM and MIMO techniques combine together in order to achieve these two benefits, that is the improved signal quality and spectrum efficiency. Next, let us see the next technique, that is adaptive modulation coding with time slot scheduler. We know that wireless networks uses a time varying channel, so that the packet losses may be common in that due to severe fading. So this is so ultimately what happens is the degradation of the wireless performance, because there is an inefficient utilization of the available radio link capacity. So the performance gets degraded. So what we can do that? So in order to overcome this, what is done is a single automatic request repeat scheme, that is ARQ. We say it as ARQ, as you know. It is this scheme is combined with adaptive modulation and coding system, and the time slot scheduler that uses the channel for predictions. So what happens by doing this is that the time slot scheduler shares the spectrum efficiency between the users. Therefore, it is satisfying the quality of services also. That is, the requirements what is being fixed is also being satisfied. So that is the main idea. And the next important topic what we are going to see is the cognitive radio, right? So cognitive, before going into what is cognitive radio, let us see some of the basis of wireless telecommunications. As you know already, without spectrum, that is without the idea of spectrum, the wireless telecommunication or wireless internet services is not at all possible. So cognitive radio is the main technology, that is it is the radio technology which is lying behind all these principles. That is, it also includes the revolutionary change in how the spectrum is being regulated. So cognitive radio and 4G are the two words that are complementary to each other, when it comes to wireless communication. So cognitive radio and 4G technology can be never seen as two separate technologies. They are complementary to each other. That is what I come to say. Okay, so let us see the proper definition of cognitive radio. Cognitive radio is a goal-driven framework in which the radio autonomously observes the radio environment, it infers the context, it is accessing what are all the alternative possibilities, it also generates new plans, it also supervises the different services including the multimedia services, and it also learns from its own mistake. So this is what is actually a cognitive radio is. It is similar to that of an ad hoc based network. So how FCC defines it as cognitive radio is that, first of all I'll tell you what is FCC. FCC is nothing but it is the abbreviation of Federal Communication Commissions, right? So how they define it is cognitive radio is that it is aware of its surrounding and adapts intelligently. That is, it is nothing but it can transmit, it can change its transmitter parameters based on the interaction with the environment in which it operates. So this is what is a cognitive radio means. Now in the next slide, let us see what are all its main functions. Right, coming to the main functions, and it is also built on SDR. SDR is nothing but software defined radio. Let us see about software defined radio a little bit later. First let us see what are all the functions of the cognitive radio. The very first function is that spectrum sensing, the second one's spectrum management, third function is spectrum mobility, and the fourth function is spectrum sharing. Let us see what is the meaning of spectrum sensing. The very first function, that is the cognitive radio determines which portion of the spectrum is available and detects the presence of licensed users when the user operates in a licensed band. That is what is called as a spectrum sensing. Now coming to spectrum management, it will also, the cognitive radio will also select which is the channel, which is the best channel available from all the available channels for the communication. So that is what is called as spectrum management. Coming to the third function, spectrum mobility means it will vacate the channel when licensed user is detected. That is, when a non-licensed user is using, and when a licensed user comes to use, it will vacate the channel and it will free the channel for him. That is what is spectrum mobility. Then coming to the last point, that is spectrum sharing. It will coordinate the access in this channel with the other users also. So that is what is spectrum sharing. So these are the four functions, and let us see in detail about the fourth function, that is spectrum sharing. That is what is more important. You always know that, you already know that in general there are only two users in a cognitive radio network. One is a primary user, the second one is a secondary user. The primary user uses the channel of the transmission, and the secondary user tries to be in the channel in the opportunistic way. Yes, so what happens is the secondary user tries to find an empty space in the transmission channel and also to remove the channel when the primary user starts to use the channel once again. So the secondary user accesses the channel is considered the secondary user accesses the channel, but this access should not be interfered by the primary user also. That is also to be taken into consideration. Okay, so this is what is called as spectrum sharing. Next, This is the cognitive radio architecture. It is clubbed with our software defined radio. So what we can infer from this figure is that the cognitive radio encompasses the SDR, right? So the SDR is developed in a software based on digital signal processing with the modifiable radio frequency components. Therefore, the SDR is a radio platform. It is a generic general form of a radio platform which is also capable of operating in different bandwidths. And also it can operate on large number of frequencies also. And also it can support many communication standards like GSM, WCDMA, WiMAX, and it can also support several multiple access techniques also, right? So this is what is the inference what we refer. Then coming to the benefits of OFDM, as you know, it is used, the first benefit is the optimal diversity, spectral efficiency, improved quality of service, benefits to the service provider, benefits to the regulator, and these are some of the applications listed. There are several other applications of cognitive radio also, and let me point out one or two which is not mentioned in the slide, which is not mentioned in the slide. That is for the upcoming internet services also it can be used where high data rates, seamless quality of service is required. We can use this cognitive radio, and multimedia downloads can also be implemented with the help of this, and communication during emergency services, that is military surveillance, etc. And finally, other multimedia services like anything like audio, video distribution which require a higher data rate can make use of this cognitive radio. And let us come to the SDR, right? So I said that we can see a SDR a bit later, right? So SDR is nothing but, once again I repeat, it is a software defined radio, right? So it is used for handling more than one communication technology. Take for example GSM, CDMA, etc. The main purpose or goal of developing this SDR is that the radio, it should be able to design a radio that can receive and transmit a new form of radio protocol just by running a new software. This is the main idea. That is, a hardware change should be possible by making small changes in the software. That is the main idea behind this, and it is mainly used for IPv6 transition. Already we are in IPv6, that is due to more number of users, the IP address provided for the number of users is not sufficient in the previous IPv4 technology, and in the IPv6 it makes use of a 128-bit address, so that more number of users, billions and billion number of users can be eventually added, so the number of users can be increased. And these are some of the examples of already we are in the 4G technology, but these are some of the examples of the 4G 4G technology devices. And finally, the last is the 4G to 5G transition. What we can infer from this is that already some countries have implemented 5G, and what is expected out of 5G is that it should be more beneficial in terms of services, quality, speed than the 4G technology, and it should prove to be a more intelligent technology providing an unbounded global connectivity. That is what is expected out of 5G technology, and hope in future 5G technology comes to India also, and we all get benefited in an useful way. Thank you.